All right, we're gonna get started here with Ben Shear. Ben's been using our product for a really long time, does a lot of training and golf instructions type stuff, works a lot of tour players. So I'll turn it over to you.
All right, thanks, Scott. All right, so this is gonna probably be a little bit different than anything any of you guys have seen anybody talk about. I'm gonna talk about more using the plate for some athletic type testing, and then talk about how that then applies to the golf swing. I mean, I think one of the cool things about getting involved with doing athletic testing on the plates is you get rid of the complexity of hitting the ball. And if somebody can't perform a certain task or movement pattern that you're trying to create in their golf swing without hitting the ball, certainly when you throw the ball and trying to put the ball in play, we know that that task is probably going to be really hard. And then you can learn as a golf professional, hey, the person can't even do this physically. I'm wasting my time trying to get them to do X, Y, or Z within their golf swing. So one of the things I've been looking at recently, and I have a bunch of different tests, and if some of you heard me do before, I do stuff looking at stretch shortening on here and looking at counter movements versus non-counter movement jumps. But one of the things we're looking at really right now, for me, is I'm looking at, we often talk, for everybody who's been using SwingCat, we have the horizontals, the verticals, and the torques. But one of the things, I think we look a lot at the timing of that horizontal force, but for me, it's the braking of that horizontal force that is really what's contributing to speed, and how we brake and stop that. And if we look at people who are really good big hitters, you will notice that their peak braking force, you know what, Drew, can you just line up that braking force here with this peak vertical force? So this is Josh's graph. He obviously hits it like 400 miles. So this is a pretty good example. But if we notice here, he's got a little double peak. I don't know if the mat maybe moved or whatever, but you can notice his peak vertical force and his peak braking force line up exactly together. Okay, his peak vertical force and his peak braking force line up together. And you see this over and over again with good players. People who are not so good do not do it, and it doesn't even matter how much braking force you have. I mean, it does matter. You want to have more, and more is better. But even good players that I have tour data on and stuff like that, even if they don't have a massive braking force, the guys who are really good still line those up. They still line up those two things. And why is that happening, and why is that important is something that we can test and that we can start understanding. So basically, we're all trying to make this transitionary move. And so what I've been doing with the test is I have people stand on, you don't have to capture this right now, but I have them stand on, hop off, hop on, hop up. Right? So now I want to be, can I break my jumping on? And can I take that lateral and bring it into a vertical component? And when I do it, if I do it well, those two things should line up. And what am I trying to do, really? What I'm trying to do is get my center of mass over this position. So basically what I'm doing is I'm using vertical force as my lateral brake. So instead of feeling like these are all independent things, whereas I make my move, I gotta have my shin angle like this to create a really good lateral brake. And then I gotta move it over so I can turn. And then I gotta get my knee flex and so I can push. And so I have to do all these things, right? We got 0.3 seconds on the way down. It's really hard to do all of them as independent pieces. So the more I can use the same muscles and the same body parts to accomplish 2 jobs or 3 jobs or whatever at once, the better, right? So if I have enough vertical force, it will break my horizontal force, right? Does everybody just follow somebody? If I have enough of this, it will stop this. It's a math equation of how much of each it's going to take to do that. But if I can do that really well, I'm going to have a really good chance of being able to break and do those things. So the more our center of mass lines up with, I'm going to call it my shin angle, right? I use a term, I was saying to Scott, I use a term positive and negative shin angles. And what we mean by that, I'll give you the track example to start, and then I'll give you a golf example. So in track, if I was going to run sprints and my shin angle was like this is not going to be very efficient for me to sprint that way. That's a pulling motion versus if I was in this position and we're looking at that same leg where my shin angle is now pointing backward, that's going to be really efficient for me to create a triple extension, ankle, knee, and hip. to generate and propel myself forward. Same thing holds true in these graphs, right? So from a golf perspective, if I'm looking at my lead leg, right, the more I got my shin pointing this way, the more that's a lateral break, if that makes sense, right? This is going to break lateral force. If I'm moving this way, the more my shin goes this way, the more it's going to break lateral forces. The more it goes this way, and certainly if it goes this way, I am not going to break lateral forces. If I want to create verticals, you get some players who kind of hang back. Well, it's hard to have a lot of verticals if my shin's pointing this way. If my shin gets vertical, really easy to start creating vertical force. So I think one of the things we talk about, and everybody wants, arrows and graphs and all kinds of cool stuff on here, is that, and obviously there's some outliers to this conversation, but in general, you can look at the angle that the shin is pointing and say that is the direction of the force they're putting into the ground. If you look at the angle of the shin, that is the direction of the force going into the ground. So I want to have somebody come up here. And then, just to finish up on this, in this example, if my leg is like this, my center of mass is not aligned up with that force vector. If I get my things moving this way, the more I can make my center of mass over that vector, the easier it's going to be for me to do something, right? Lining up our center of mass with the force. So who wants to come be my guinea pig here? Test. Nobody can volunteer? Come on. But you're a pretty good player, right? Yeah. So good players are going to do this well, hopefully. Or I'm going to look like an idiot. So what you're going to do is I want you to stand on your left foot. I want you to hop off, hop back on, and hop up. And you can do it slow first time. Don't even capture this one. Let's just do a learning curve here. Hop off, hop on, and up. Yeah. So now we want to, don't worry about how fast this is. The key fast part is when you hit here. I want you to brake as fast as you can and get up in the air as high as you can quickly in this transition. You ready? 1, 2, 3, go. Yeah, not bad. So we're going to look and we're going to see, could he break it efficiently? Does his peaks line up? Do his peaks line up? What's your club head speed? It's 171. We'd say that's pretty fast. Well, that's ball speed, huh? That's like, what's it, 115, 118? Yeah, okay, 160, 170. So let's go here. Can you just, again, Drew, I just set my markers kind of anywhere. It doesn't matter. But just to look at where his peaks are.
Keep going. That's for landing. Keep on. Still watching. Go forward. Carolina. Keep on. Right there. Yeah.
And right there, again, I think some of this is a little bit under the landing. But I think that this moves a little bit. But we can see, generally speaking, his peak here and his peak here are lined up exactly on top of each other. And I would say he was a little bit inefficient. You can see when he kind of came down, he actually started falling to the outsides. In general, not that I want to coach initially when I'm doing my assessment, is I would want to see, if anything, you go back, right? That if I'm going to plant and I'm going to do that jump, if anything, when I jump back up, I want to go this way, because obviously, at least with a driver, I'm going to then, from an angle of attack, I'm going to hit more up on it and do a bunch of other things. So I would want that lean going that way. So this is a really good, little, simple test that you can do, because you're going to see a lot of your people with really bad braking forces. Really bad braking force is a big problem for speed, right? So you basically create speed, and again, I don't want to get over technical, but we're trying to create what we call angular impulse. That's what's creating speed to what we're doing. And we do that in two ways. We have kind of this transverse plane or rotary torquing, and then we have a frontal plane or kind of side to side torquing. And that has happened not from the pushing down the target line, it's from the breaking down the target line, and then the rotations combined with the verticals are going to contribute to how we do it. So obviously he's pretty good and we see good stuff. And what we can do is let's look, if we start looking at him here, we can look at his, can you just scroll the video back like a couple clicks? Like, let's just toggle through as he comes into impact, like impact with the ground, right? So you can see here, as he's trying to start his braking force, right? What do we see? Stop. We see this shin angle, right? His shin is pointing away, right? And what I can see there is he's got a nice amount of eversion of his foot. His foot's able to pronate. He doesn't You'll see people who have bad ankle mobility, when they go into that plant, they'll start flat and roll to the outside. People who have good ankle mobility will start inside and roll to flat. So we're gonna all, due to momentum, move, let's call it one, like we say we have inside, flat, and outside. Everybody's gonna start in one and go to the next one at a minimum, right? So if I don't have ankle pronation, eversion, whatever, I'm gonna struggle because I'm gonna start flat and go out. And once I go out, it's pretty hard to get vertical from here. It's pretty hard to break from here. It's pretty hard to do a lot of things from here. So if I can get this in and then roll to flat, I get this initial break here, vertical then kind of becomes my wall that I run into, for lack of a better way of saying. So let's toggle a little bit forward as he's trying to take off. Right? And you can see how he's trying to get his center of mass over to here, and this leg is straightening. Right? His center of mass keeps moving, and where I would say he's got a little bit of a core instability here. You can see he kind of stays in this little bit of a flexion position, doesn't get full extension there, and that's what gets him to come to the outside, I think, as he ultimately comes down. Good. Right? And you can even look how far he moved on the plate. Right? You see from takeoff how far he landed to his left in this example. It would almost like you could put like, oh, if you put a little X tape on it, say land on the X, jump up and come down on the X, as a way of thinking, or to the inside. Does that make sense? Right, so you can see he does a really good job. Other people, when we do these testing, who have big core instability problems, you'll see they jump across and their upper body is kind of hanging back. Or when they hit the ground and they go to plant, they can't control it and they're trying to jump and this thing is still going this way, right? So they have some core instability in this frontal plane. Take those people and say, show me a side plank, and most of them can't last very long, right? Or you'll see, again, or you'll potentially see this foot thing. Think of the core as a transducer of energy, right? A lot of times, some of the tricky stuff when we use ground reaction forces, where we get lost, and sometimes you'll get a graph and you're like, man, it just doesn't make sense, because what they're doing is so awesome at the ground, but they can't actually get it out to the club because their core stability is no good. So as they're trying to transfer this energy from the ground up and out, it's just being lost. And so you go, man, this guy's a triple threat. He's got this, that, the other thing. He's got all this awesome stuff going on, but he swings at 85. Well, what's the problem? The problem isn't what they're doing. The problem is their ability to transfer what they're doing, right? So we got to understand that what we're seeing is what you do. It's not why you do it. It is what you do. And then our job as either a golf professional, fitness professional, whatever, is to be able to then step back and say, oh man, look what's going on in this guy's ankle. I'm not really sure, but let me take a look at his ankle. Oh, look, obviously nice, this guy's got a nice straight line here, really good. But if the person's shoulders are like this or like this and their core is positioned, well, now I got to check what type of core stability this person has to do it. But the more we can line up your center of mass, like if we start drawing a line through him here, it's pretty close, right? If we put a dot at his belly button, let's say, right? He's trying to get that center of mass over that base support. The further, the more this stacks up, the easier it is. The further away this gets, the harder it is, right? So the more your center of mass lines up with your base of support or your force line, I'll call it the force line, versus the base of support, the easier it is to move. If I'm trying to move vertical and my center of mass is back here, and I'm trying to create a force line going this way, man, that's going to be a problem for me. So you can start understanding how you can use this type of technology when you look at somebody who swings, let's just say, and you do your swing assessment, and all of a sudden you look at their braking forces, and then you look at their vertical forces, and the timings, the peaks don't line up. I mean, if there's one takeaway from this, is it is most efficient to have your lateral braking force and your vertical peak force to be happening at the same time. Those things should be happening at the same time in the optimal world. And basically that's happening because you're basically using one set of muscles, joints, ankle, knee, hip, right? to do two purposes. You're using it to be your brakes simultaneously while using it to be your vertical creator. Does that make sense? And so I think this is a really important idea for a lot of you to start understanding, because we talk a lot about the horizontal force. We don't talk enough about the braking horizontal force. And then how is that braking horizontal force created? Like I said, I could create it by making a big shin angle that goes like this. This is a really good brake. Like if I said to Scott, come up here, and I'm going to push him laterally, right? What is he going to want to do? So just stand there. Just look how he wants to push back. He wants to create that big shin angle this way to create a vertical force. That's why overdriving laterally, in my mind, in a golf swing is dangerous, right? Because if I'm not saying you don't want to have lateral movement, but if it's just a nice, easy bump move into it, I can just use my verticals to stop that. And it's not going to be a problem. If I drive really hard laterally, I'm going to need to get that angle like Scott just created. And then that's going to kill my verticals and my rotaries. So I think if you start looking at how they're lining up their force, like the shin angles, with where their center of mass is, you can start understanding how you can create a more efficient system. And the more those things are not aligned, the harder. The more they are aligned, the easier. We're trying to make golf easy. Golf's already hard enough. And it's cool to look at all this stuff, but there's, and I say this in the truth, those of us involved, we are still learning. We don't have all the answers. We are all still learning. We're finding new things. We're observationing things, testing, retesting, trying, creating new little tests, doing all that kind of stuff. So we don't have all the answers, but I think, we have guys like Scott, myself, people in Europe, all over the world, looking at this every day, Drew, and asking questions. And we just keep learning and getting more and more knowledgeable and start understanding what of those graphs actually matters. What translates to speed, what translates to stability, what translates to whatever. And I think this is just one example where I was trying to show you how you get a 2-for-1. And if you can get 2-for-1 in a downswing that takes 0.3 seconds, that's pretty good, because you're not going to have time to go lateral break, line up, twists, turn, vertical. It's over. You don't have time for that. So how do I create an alignment system where my center of mass and my force lines line up the most efficient way, where I can use the same muscle groups, the same joints to do multiple jobs at the exact same time? And this is a really simple test. Again, he did really well, but you will see people that are not even close. Because for them to get this under control takes them a lot of time. So you don't see the verticals. The verticals are happening much after, because they literally can't create the stability to do it. Any questions?
So in that case, if somebody's in bounce, what do you work on?
So first I want to look up the chain. Is their foot and ankle in a good position? If it's not, that's where I'm going to start, because that's the thing connected to the ground. And sometimes it might not be good, but you screen their foot and ankle and you might say, oh, it's actually okay. And then you say, okay, now I have a technique problem. That's one thing. Or you screen them and go, man, you know what? You lack eversion or pronation or whatever. We got to clean that up before we're going to think we're going to make that better. I have a guy I'm working with now. He's a 3-time All-American wrestler. He's got all kinds of ankle and other problems. And he came to me and he's like, dude, I'm the strongest, most jacked guy I ever played golf with. I can't hit it anywhere. And you look at him and he's literally in his backswing, he's like outside like this. And you look at his thermography of his pressure graph and you literally see almost like a straight line on the outside of his foot. So first of all, from a timing perspective, the first thing he needs to do is like, oh my God, I got nothing to push with. I got to get going this way. And I got a bunch of other stuff. So just timing and sequencing wise, he's already done, right? So assuming it functions, then I want to say, where is this? Where is the center of mass lined up relative to that force line, that shin angle? Is it pretty close? If the answer is it's pretty close, then they should be able to be okay. The further apart it gets, the worse it's going to get. And then you can start saying, okay, I got to look at core stability, trunk controls, all of those things. And then if they pass those tests, again, you know it's a technique problem. Or if they struggle with those things, you know, hey, look, if you really want to get speed and you really want to do these things, we got to start creating some stability in the trunk or mobility in the foot and ankle or whatever the case may be. But between the thermography and all the charts and just simplistically the video and the ability to draw the little dots and lines, you can see all of this really fast and really easy. And if you just start understanding the shin angle concept, is a really easy way to understand direction of force, right? It's really hard for me if my shin is like this, for me to go vertical or for me to push that way. I mean, you gotta show me how I'm gonna push that way from here, right? So that's my wrestler guy who gets like this and he's outside, but now he needs to go over there. Well, how's he doing that? He's got nothing to push with, right? So it's almost like he's gotta like he has to now lean this, move his center of mass to the left to get his foot to flatten, and then has something to push with. But now from a timing and sequencing perspective, he's already toast. It's over, like you can't catch up. It's too fast.
Are there shoes that would help?
Of course, there are always, look, shoes is a huge thing. We were talking about this a little while ago. Shoes are really important. But there's not like, hey, this is the best golf shoe. There's, hey, this is Joel's best golf shoe. This is Aaron's best golf shoe. You know, this is Drew's best golf shoe. Like we've seen like when Justin Rose, as an example, went to like deconstructed shoes, he got a lot better. Well, Justin Rose has a retroverted pelvis. So having a little extra motion helped him. Look at John Rahm, who's got all of his issues. He's got really soft shoes. Because he doesn't move really well, and he's got leg length discrepancies and club foot and all that stuff, soft shoes allows him some freedom. You get somebody who's really mobile, especially like if you have female golfers, really rigid, stable shoes tend to be way better for them because they have lots of motion, but they're trying to control the motion that they have. So really stiff shoe. And like this is always the conversation I have with my amateur. With tour players, it's easy, right? It's about money, it's about golf performance, it's about that stuff. But with my amateur golfers, the question becomes like, hey, do you want to wear shoes for the walk or do you want to wear shoes for the golf? And those are two different things. Like the typical person is walking 7 miles. If you're miserable and uncomfortable in your shoes, a lot of people are just like, I hate this. It's like, but those shoes are killing your golf. Now you got to make a choice. You know, do you find the middle ground shoe? Do you say, you know what, I just care about my golf scores? Or you're like, hey, look, I play golf for fun. I'm out here on the weekend. I'm just trying to have a good time. I wear dress shoes to work all week. My feet are killing me. I just want to have a nice walk with my friends, and the golf will be my golf. Right? So I think you got to figure out where each person, for their own goals, aligns with that. So there's no right or wrong answer. It's like, what do you want? If I don't care about my score, then maybe comfort's the most important thing. I care about the walk. And especially if you're carrying your bag and it's a hard walk and you're playing on a hilly course, you know what? Stiff shoes is not really enjoyable for a lot of people, even though it might be better for their golf. So you're always kind of trying to balance and find what is the right combination of those things for each and every individual and what they want. And there's no right, it's not for you to say, oh, this is the right shoe for you. It's like, hey, what is it? Here are the trade-offs. The good and the bad. Now you make the call and just understand that if you sacrifice one for the other, just be aware that that's the trade-off you're making and it's okay. Anybody else?
No other questions. Thank you, man. That was awesome.
Yeah.
If you have any questions for him, feel free to come up and ask. Thank you.